Today's event is what we call an experts corner. Jim's going to lead us through a couple of the questions we got on the phone, three I believe, that we received before the event started. And then we'll take whatever other questions we have time for until we run out of time or we run out of questions. We've also got a couple of other experts. We've got Carolyn Carter, who's the product manager for the Certification Tools product line, and Adrian Young, who is, well, he's Adrian Young, right? He knows a lot of stuff. He's actually one of our planners for our new product ideas. You've probably seen him on some of our videos as well. So with that, I'm going to turn it over to Jim and take us through the first questions that we received over the last week. Jim, let's see those questions.
There we go. Hey, good morning, everyone. Thanks for the introduction, Mark. So, yeah, we're in a new world and we're trying new things, and we had this idea that people might want to talk through some questions. If you have a question, info@flukenetworks.com. Outside of the webinar, of course, on the webinar, send it to us there. So we asked the other day for some questions, and we got some questions. And we went through those and some questions we've seen over time to try and come up with some things that we can answer, get some conversations started. But we're happy to go in other directions as well. We also are going to have, we're trying to make this a weekly event, and we've got, is next week the labeling snack size webinar, Mark?
That is correct. Yes, we'll be doing one on labeling and cable identifiers.
All right. So this is short
for that.
Yeah. So this is short and sweet and to the point. So let's cut to the chase. So we got this question. I'm sure you've all read it by now, and this is a fairly common one. This is where somebody says, "Hey, I have this old fiber. Will it support a new application?" We don't quite have all the information that we would need in this question, like, is it multi-mode or single mode? But let's address this question. I'm running 10 gig today. I'm thinking about running 40 gig tomorrow between 400 and 1,000 feet on some, oh, and they did say single mode fiber. Well, we didn't read that yesterday when we were looking at the question. But let's answer this. So what we wanted to address today was the possibility that you would look up what are the parameters for the next application that you're looking for. So here on the Fluke Networks webpage, under support and downloads, you can see a rather interesting document that we put together that's the Versiv limit lines document. I'm going to jump over into the limit lines document here. And this is all of the different test limits that are within the tester. Sometimes people will say, hey, I need to measure this thing or that thing. Yesterday, somebody said, I need to measure insertion loss out to 1 gigahertz. What test limit will measure out to 1 gigahertz? We can look that up here in this document. Now we're talking about fiber, and let's zoom in on this a little bit. So let's pretend that I didn't just read that they said single mode, because our first part that we wanted to answer to this question was around multi-mode. Multi-mode going from 10 gig to 40 gig. And what this chart is showing us is that we have a loss value for the different multi-mode parameters. And Adrian, you like to talk to that column on the right. Could you take us through this for a moment?
Yeah, once I take my headset off mute. So one of the things, and we'll definitely answer the single mode in a moment, is, but pertinent to multi-mode, is people focus on the fixed loss value. They're like, wow, I got better than, I don't know, 2.6 dB, therefore I can run the link. It's really important to go all the way to the right-hand side there and look at the length. You cannot exceed those lengths. What happens when you exceed those lengths is you get something called dispersion. That's when the zeros and ones become gobbledygook, and that's when you start getting errors on your network. And unlike copper, where it gradually gets worse as things get worse, in the fiber world, it's more of an avalanche. You'll find that you may be able to squeak past that 300, and there comes a point, and then it simply just crashes and stops working. So it's very important to keep an eye on that length requirement there. Don't just focus on the loss requirement. Make sure you understand the length requirement as well. But to answer the question on moving up to 40 gig, if you're running 10 gig LR today on that single mode link, and it's what Jim said, 300 to 1,000 feet?
Oh yeah, 400 to 1,000, about 300 meters.
Okay, we can definitely go down here and look up the value, but on the length issue, which typically comes up, obviously with single mode, you can go a lot further than multi-mode typically. There are a couple point values for length when we talk about single mode, one being 500 meters, the other being 2,000 meters, and then 10,000 meters. And that's because when you're talking about the enterprise or campus networks, that's the three options you're given. The 500 represents the new generation of transceivers designed for data centers, and that's probably not what we're talking about here, because they're talking about the backbone here. So you're probably looking at a 2-kilometer version. So we can run down this list, but what we wanted to highlight here is that there's a single place document where you can actually look up all these loss values. Now, this list is not fully complete because there are a lot of proprietary solutions out there, but you should be able to get to that answer from this download.
All right, thank you for that. Okay.
I might add one more comment, and that is that download is available for free. You do have to set up an account to be able to access downloads, but there's no charge for that document. And Jim is one of the guys who puts that together. It's a lot of work, but there's a tremendous amount of useful information in there.
And we missed a second part on that question, if you can go back up there, Jim. So there was a question on there. It's like, well, you know, what is the best thing to use to figure this out? Given that it's a 20-year-old fiber, this is a personal preference. I would rather turn to an OTDR. Typically, I would use an optical lens, and yes, we would do inspections. But that's 20 years old, that fiber. I want to make sure that nothing untoward has happened to that fiber, and that OTDR will actually allow me to look down that fiber cable and see if something has happened to it in the past 20 years. Who knows what adds and changes and questionable rerouting of cable has actually gone on during that process.
Okay, and heaven forbid your local carrier came out to bury some cable and bumped into that fiber. We're not going there.
Don't even start me. Wait, just for the audience, we're joking there is I had some cable from my provider mold to my house. They weren't content with it taking out the sewer line. They took out with one leg of the buried power line, which was resolved yesterday. So luckily I can do this webinar today, so that's nice. Anyway, Jim, back to you.
Okay, so here's a question that's kind of general but typical, and people say, hey, sometimes I get more loss at 1550 than at 1310. And I thought there was more loss per kilometer at 1310, so why am I getting more loss at 1550? Now, we wanted to give a visual representation to answer this. So what I have here is our trusty Fluke Networks Versiv tester, and I'm actually going to use the Certifiber Pro module. This is a loss test set, so I have a single mode port and a power meter. And what I'm going to do is a loopback. I'm just going to send light out on this 100-meter launch fiber. I'm going to send light out and have it come back to me. But I wanted to also show you a part of the tester that you may not have seen before. Here within the Tools menu, we have this power meter and light source. So we can use this. We're measuring single mode, and we're not measuring anything, so I'm not sending anything. So let me send out 1310 and 1550. So I'm sending 1310 and 1550, and you can see that we're measuring in dBm. dBm means we're measuring absolute power. This is a great starting point. If a link is not coming up, let's see if any power is coming out. Now, the question was, what happens if I get more loss at 1550 than 1310? So what I'm going to do is I'm just going to put a little bend in this fiber. Not a lot, because launch fibers are hard to come by these days. And you see how 1550 is increasing in loss there. So when you have greater loss at 1550 than at 1310, that suggests that you may have a bend or a crack in the fiber. Now, to find the distance to where that event is happening, and I'm sorry, I'm not going to do this as a test, but I just want to show you this test result. We can use an OTDR, and it can show us the distance to where we're getting a bend in the fiber. This has a very distinct feature on the trace. I'll just zoom in here on this trace. And these are both the 1310 and 1550 wavelength. You see at 1310, very little is happening. But when we go up to 1550, we see that the longer wavelength is more susceptible. Of course, we'll use the expert module in the tester and have it tell us that there's a bend happening there. All right, we are scooting through our time, so let's jump quickly here to our next question.
Hey, Jim, this is Mark. I was just going to throw out, there's a question that came in, and they said, what's the difference between Versiv and a Certifiber and an Octafiber and a DSX? I think you just did a great example of showing what that is that the same platform, the Versiv platform as we call it, has a power meter, an optical loss test set with a power meter in it, which you were just demonstrating, but that mainframe could also have an OTDR in it, and you had swapped the module out, made the measurement with the OTDR, and then the measurement stayed in the tester when you went back to your optical loss test set. So that's a good example of how Versiv works. It's the same user interface, you just have different modules for optical loss, OTDR, fiber testing, or copper testing.
Perfect, thank you for that. Hey, we had some fun with this question. This actually is a question that we received in the webinar last week. We're not really making this up. And I'm sure our TAC group, if they're listening in now, are pointing at the screen and screaming, yes, yes, that is the most common question that I get. Help us out. What test is it failing? What tester are you using? Especially if you can send us test results. If you can send us that .flw file, that's very helpful for us. So we're futzing with this, and we were thinking about what is a really common failure that happens that is a little bit more operator error. So what we're going to do now is jump into a copper test, because we know that people mainly do copper tests. We're using, if that'll focus, DSX 8000 here. All right, it's not going to focus, but trust me, we're using the copper module. So we're going to jump in and we're going to set up a test. I have some new 5E cable, so I'm going to test a 5E link. So what people mistakenly will do is select just a 5E cable and not change the test limit. They'll say save, use selected, and here we are live without a net. We'll push test to start. And we'll find out that our remote turned off while we were waiting for the webinar to start. Now the main is going to tone, which will turn on the remote. Turn it on myself while we wait here. It turns out you can get up too early in the morning and start preparing for these. And we get the happy noise that they're connected, and let's run the test. So again, what we're showing here is, why is my test failing? And this is just a common mistake that people make. They configure just the cable type and they don't configure the test limit. So we've been looking at this for a while now, that it's a Cat 6A permanent link test, but what I bought was category 5E cable. When you see that generating diagnostics, that tells you that there's a problem. Oh boy, we're failing all kinds of things. Return loss next. We could jump into fault info, but again, I don't think the nature of this question is it failing for return loss or next? That's another discussion. And fault info is telling us, hey, we may have a problem with the cable. But let's go back to home and let's show the right way to do this. We want to be careful. I'm going to edit this test result. We need to be careful to select the test limit. It's the test limit that's going to decide whether or not a link passes or fails. The height of the overpass, if you will, on the road that is our cabling. Now, as fate would have it, again, this is live and without a net. This cable has reliably been failing Cat 6 and passing 5E. You'll notice, of course, as of this morning, it's decided it wants to be difficult. Now, I think we're not going to fail. I think we're going to get a marginal result here. We are going to get a marginal result. So the expectation was the person is failing because they selected the cable and not the test limit that they wanted. And as a result, they're getting a problem. We didn't want to talk about this star pass, but let's take advantage of the opportunity this lemon to discuss star pass and return loss. So I'll zoom in on return loss. And what this is telling me, the star pass, just zoom in here a little bit. What it's telling me is that on the 1-2 pair, right here at this low frequencies are generally cabling problems, about 15 megahertz. The measured value is very close to the limit line. And when the measured value gets close to the limit line, we get within the accuracy of the tester, and the test standard for field testers tells us we must put an asterisk on this test result to tell you that it passed and it's on the border. Now, whether this is acceptable or not, that depends on your customer and if they will accept a marginal test result. All right, moving on to our next question here. And related question, this great 5E cable I've got, it's passing 5E. You saw it's a pass, it's a star pass, but my PoE device is not working. The switch in the device manufacturer, I called up and I said, the switch isn't working and this device that I'm hanging off the end is not working. They apologized profusely and sent me another one. Those didn't work either. I called them back to say, I can't believe they made 2 bad devices. They suggested it might be the cable. And I said, oh, come on. You always say it's the cable and we know it's not. Well, let's take a closer look at these test results for a moment. One of the things that is interesting, in order to run PoE for the Ethernet, yeah, we need return loss and next. Those are in good shape. But for power over Ethernet, we're really interested in this resistance value. You'll notice resistance is reporting a letter I, that mysterious letter I. Why, Jim? Why does it not pass? Well, this test limit, the TI 568 permanent link limit, does not require me to do a loop resistance test. So I've run a loop resistance test, but there's no limit line. So it's not going to tell us if we can pass or fail. So what I'm going to do now is make another change to my test. So we'll go into our test limit. We're going to edit it. And what we've been suggesting to people is, here are the tests that are available. I'm going to go to More. I'm going to select TIA tests. It's just category 5E. But what I'm going to select is a test with this suffix here of plus PoE. This plus PoE suffix is going to take a look at the loop resistance and the resistance unbalance values of the cable to make sure that they are within the specifications. The 568 standard for the cable and the application standards for power over Ethernet identify that you do need to have good loop resistance and resistance unbalance tests. When we add this plus PoE, we're actually going to look at those values and, hey, here we are. Return loss still exactly the same. I didn't change anything. I didn't move anything. We're passing insertion loss and next. But the resistance value, the limit is just 21 ohms for 90 meters of cable. I have 25 ohms in this short 50 meter length, 50 some odd meter length. So what we're seeing here is that we do want to add this plus PoE tests if we want to make sure that our cabling is able to support power over Ethernet. All right, there we go, running over our time, talking too much. Let's jump out and run to the crowd for some questions. Adrian, do you have a question there from the crowd that you'd like to answer?
Yeah, actually, I was just typing the answer to it. How concerned should I be when my contractor submits test results with a generic cable type, i.e. 6A, as opposed to specific manufacturer's cable where the values such as MVV can vary? Great question. First thing is, what is MVP? It's nominal velocity of propagation. Any scientists out there, listen carefully. It's the speed of the signal in the cable relative to the speed of light in a vacuum. All kind of exciting stuff. So generally as a whole, the signal in the cable travels about 2/3 of the speed of light in a vacuum. So that's why you end up with MVV values of 66 or 68%. The MVP is, the only thing MVP affects is the length reading. That's all it affects. So you can get hung up on this. If you're in a state where bidding is done per foot, then obviously having the MVP as the correct number in the tester then becomes more important. It's not the end of the world. And the other thing is if you want to, if you get the results in Linkware PC, the FLW file, you can actually recertify the results with the MVP value that you would like to see what that cable difference is. And you'll probably see it's actually very small, so it's nothing to be really concerned about. But if you are concerned about it, definitely talk to your contractor and say, hey, please enter the correct MVP, but it's not the end of the world.
Adrian, another thing on that point that I'll mention too is that the tester, I believe, measures the delay time, which of course is not dependent on the MVP, and there's a spec for that. Is that correct?
Yes, there is something called propagation delay, which is a time of flight, how long it takes a signal at 10 megahertz to get down to the end of the cable. And that's how we actually calculate the length. By knowing the MVP and how fast that signal travels down the cable, for that particular given cable, if we measure how long it takes to get that signal down the cable, then we can figure out the length reading.
You know, one of the questions that we got this week is, what is your favorite FLW file that you've got? And we decided not to answer that question. But since you guys have brought it up, I thought I would show you this test result. We can see that this test result is failing. And if we zoom in on the details of the failure, we see that the wire map is in good shape. And the length, while 101 meters is a little bit long and 103 meters is long, it's passing because we get an extra 10% there. Now, the problem with this cable is, as Mark was mentioning, that time to get from one end of the cable to the other, the propagation delay, you get 498 nanoseconds to get to the far end. This cable is 499 nanoseconds long. That makes it 1 nanosecond too long. Simple to solve though. All you need to do is push the wall 1 nanosecond closer to the rack. Do we have another question out there we want to try and answer? I know we're running pretty long here today.
Yeah, we see one on here is we're a small company. We do about 2 to 5 copper jobs a year with a few multi-mode runs. Yes, it's difficult to justify purchasing aversive when you've got a small amount of jobs. There are 2 options on the table. The first option you are not going to like is subcontracted out to a local company. Nobody wants to do that. The second option there is you can actually rent the Versiv and the modules from companies such as TRS Rentelco or ElectroRent. There are other rental partners out there. And the nice thing about those partners is you will actually get calibrated modules rather than trying to borrow a module from one of our reps or ourselves, as you saw last week. None of our stuff is calibrated for the exact reason, so we don't do that. But yeah, I hear what you're saying is at that stage you're looking at a rental or subcontracting out to a local person until you can build up your business, and then you can start doing it yourself.
So this is Carolyn. I'm going to just jump in with one other one. So I agree with that completely. Either subcontract it, rent a unit, or the other thing you can do is a power meter light source. But if you do that, you're going to have to understand the limits, calculate everything yourself, and make the pass-fail judgment call yourself. But that is another tool you can use to do that.
All right. Another question on here is, my concern is on long runs, close to the 100-meter limit. If the MP used for the test is lower than the actual cable, will my length be skewed higher or lower? Yes. We have seen, so and Jim just showed this earlier, is you can monkey with the length reading, but you can't monkey with the propagation delay. So here's the thing. In the ISO IEC standard, length is not a requirement in the test for pass or fail. And people are like, what? What do you mean by length is not a requirement? Yeah, it doesn't care about the length per se. It cares about whether the signal is at the other end in time. As long as that propagation delay is passing, the length really is for billing purposes. But to answer your question, yes. And If
Yeah.
you change the MVP from 69% and you knock it all the way down to 50%, yeah, that length is going to be significantly less than what the real value is.
And cleverly, we should have just run a length test because we don't want to go through the diagnostics, but this is live, folks. PowerPoint, everything would work fine most of the time. So what we're going to see,
Adrian, you broke up a little bit there.
Oh, I did.
Sorry, I was just going to say, you broke up a little bit there, but I was going to kind of summarize as with you exactly. You can play around with the NVP and tweak the length up to what you want, but the propagation delay is set by physics, and you can't cheat that. So you may be able to say, well, you could theoretically mess around with the NVP, get a length that makes your customer happy, but you're still going to fail the propagation time, and so you may not have solved your problem.
All right. Starting to run long here, folks.
Hey, Jim, you were showing what the modules on the tester look like. Just if you want to show that real quick.
So the way Versiv works is Versiv is a platform, and Versiv is actually a mainframe and a remote, and then it has different measurement modules, such as the Certifier Pro modules that Jim is showing you right now, that can be put into the back. So the other thing you can do is you can change the personality of Versiv, I like to say. So it may be a Certifier Pro today, but then if I have DSX measurement modules also, I can put them in the back of my Versiv. And now I've changed the personality of my Versiv to be a DSX cable analyzer. So depending on what measurement modules you have, you can change the personality of your Versiv. The nice thing about it being a platform product, however, is it has the same UI no matter what measurement you are conducting. So your technicians don't have to relearn a measurement, the different UIs. You also have the same storage system. That means that you can have use the same reporting software, have both a copper, an OLTS, or an OTDR or inspection test in the same report. So being a platform product makes it very economical and efficient for you and your team. Thank you very much for taking everything apart. And Jim just put in an FI 3000 in there for you.
Which is a fiber inspection camera. Hey, another question has come in, which I think is a good one. You could show this on the screen, Jim. There are 3 types of resistance measurements in twisted pair cabling. These types of resistance can cause significant issues in what types of systems?
Okay, so the first measurement is the loop resistance. Let's say this is a pair here. It's going to be the resistance going out and coming back, the sum of the resistance of each individual leg of the pair. The pair-to-pair unbalance is the difference between the resistance of one leg compared to the resistance of the other leg. In Power over Ethernet, we're going to have a signal and we're going to split it. Half of the load is going to go on each leg of the pair. So if we don't have equal resistance value for each leg of the pair, there's a pair, if we don't have an equal value for each leg of the pair, that causes a problem with the transformer that gets the power onto the cable. Actually, the problem manifests itself as the data being corrupted. And finally, we have the pair-to-pair unbalance, because if the new BT specification, we're going to use all 4 pairs, 2 going out and 2 coming back. And because we're splitting the load, we want to make sure that the resistance, the loop resistance of this pair is similar to the loop resistance of the other 3 pairs.
Thank you, Jim. Here's another question that came in. I don't. Anybody who wants to answer this one can go for it. Do we still call them tip and ring?
Typically not in the world. That's a telephone terminology, tip and ring. But it's funny. You got to be aware of that, because if you are talking somebody like been doing this for 20 or 30 time, and we talk about 4 or 5 being swapped, we'll talk about a tip and ring reversal. And it's nice to know what that actually means.
Very good. Thank you, Adrian. Yeah, and of course, none of us here are old enough to remember any of that. Of course, no. All right, I think we got. There's a couple more that have shown up. Let's see. Here's one of it. It's do launch cables no longer require a coil of fiber out of the unit? Now, I don't think we haven't really talked about OTDRs today, but I think that's what we're getting at. So, Adrian or Jim, you want to handle that one?
Hey, you got a launch pack there. If you explain what the launch pack is, I answer the question.
Sure. A launch fiber is, from last week's webinar, we saw that the launch pack, or the dead zone eliminator, is a length of fiber that we use to be able to measure the first connection. If we need to measure the first connection that a fiber is making, then we're going to use the launch pack to eliminate the dead zone that happens here on the port of the OTDR. Now, the very important thing about your launch pack is that it has the same type of connectors as what you have on the wall. Here we have an SC to SC APC. Here we have an SC to LC. So if you have an LC port on the wall, you're going to need LC on your launch pack. We don't want to put a short patch cord on the end of it. Now, while this looks like a tiny piece of fiber inside of here, this is actually 160 meters. And our multi-mode launch pack, which is conveniently right here, the multi-mode pack has 100 meters of fiber in it. Does it need to be 100 meters? Probably not, but 100 is a nice round number to be able to subtract from the measured length. The defining factor of how long your launch fiber is the pulse size that you're using. If you want to measure that first connector, you need to have a launch fiber that's long enough to support the entire pulse that you're going to put into it. When we're measuring a short 100, a 200 meter link, we're going to use a very short pulse, 3, 5, or 10 nanoseconds. They're measured in time, just because engineering. So a 100 meter launch pack is going to work out to about 1,000 nanosecond pulse width. But if we're using a longer pulse width, if we're using a 10,000 nanosecond launch fiber, and we want to measure the first connector that we're getting to, then we're going to have to use a longer launch fiber to measure that.
The question that's coming, most carriers single mode with APC. I would say actually all of them cover APC. Should APC to UPC when testing? Absolutely no. No. The whole point about an APC is you want to see a very small reflection, if any reflection at all, at that connection point. If you use an APC to UPC, what's going to happen there is you're going to see a big reflectance and your customer's going to go, something is wrong. So when it's APC, no funky patch cords, no funky adapters. You want to keep it APC native way down.
Adrian, that's why, you know, the testers, at least on the OTDR side, our testers either have UPC or APC. You would want to use the exact same types of cords all of the way along. So if you have an APC connector on the OTDR, it's for testing a link with APC connectors, right?
Yes and no. The reason why Jim's showing the HDR module, all our fiber modules, with the exception of this one, have a UPC, an ultra physical contact. And you can test APC links with that. You're just in a launch fiber that is UPC to APC. The reason why this particular module is green and has an APC launch on there is it's designed for measuring high links. In other words, very long links. When you go well beyond 30 kilometers and you want to measure more than that, then it becomes handy to actually have just moving it, PC connection there, because then I get very little reflectance at that front port there. So that was a decision choice from our point of view. In the enterprise, most of the time you're going to be dealing with UPC, which is why we did UPC. But for this module on the left, which is really for long haul stuff, that's why we went to APC.
Yeah, and my understanding is on the power meter, could you a little bit about that? is the power,
Yeah,
where we're measuring power, it
meter
doesn't matter.
No, yeah, the power meter, it doesn't matter. So the input port, if you're doing an optical loss test, that can be APC or UPC. It doesn't matter. It's the output that you just need to make sure it matches. And the standards are nice. They, they do some color matching to help you out as well.
Okay, thank you. Another question came in asking, are pair unbalance problems usually a result of poor termination or something in the cable path, such as kinks and whatnot?
It is going to be normally a poor termination or a contact resistance issue. All the manufacturers of cable are required to meet resistance and balance properties. It's not actually a requirement to be tested in the field when it's installed, but the manufacturers are required to meet that. Also, the connectors have to meet the unbalanced requirements as well. And I would say if you stick with a quality vendor, you should not have a problem from a component side. But if it shows up as an issue, then the chances are you've actually got a contact resistance issue going somewhere. And I like that. I like the unbalanced measurement for that, not for the PoE issue, but the fact is when you get that call, and we had it a couple of weeks ago, the link is flaky. I test it. It says it's okay. I'm thinking, well, you might have a contact resistance issue. And sure enough, they do resistance measurements. And one of the pairs is completely wackadoodle. Sorry, that's an English term. And we can definitely turn around and go, hey, you've got a resistance issue. And then you can do the divide and conquer and start cleaning connectors and repairing connectors and see if the problem goes away. And definition of time domain.
Oh, go ahead.
Yeah, you can use the OTDR function within the DSX module to sometimes locate that problem. But yeah, to shorten that is the UBL thing is really good for identifying if you've got a contact resistance issue. That's one of those links where it sometimes works and it sometimes doesn't.
And I've heard that can be a problem, especially if you say use jacks that are designed for solid pair cabling and are punching down twisted pair cabling into them or the other way around. In other words, if you're mixing the connector type with the cable type, that can lead to resistance problems.
This really shows up with RJ45 plugs. If you are terminating RJ45 plugs onto horizontal cable because you're going into an access point and the customer doesn't want a jack in the ceiling there, it's very important to get the RJ45 plug that's designed to terminate solid cable. There are two flavors. There is one that will terminate on stranded cable, and there is one that will terminate on stranded and solid cable. And if you pick the one that's only designed to terminate on stranded cable, then what's going to happen is you're going to end up with a high contact resistance issue, and you are going to see problems.
And the bad thing about those is they are much more likely to fail in the future. They might pass the other tests now, as you said, but you may find a year or two down the road they don't work anymore because maybe they've been flexed or maybe the temperature has changed and they've caused things to move around a little bit.
Yeah, I mean, this question came up when we hosted a Bixby regional meeting here at Fluke. And once I started talking about this, everybody suddenly woke up again. Because the question was like, well, is this a requirement in the standards? I said it's a requirement the manufacturers making the components. But if you want this as an installation test, then you're going to have to actually specify this as an additional test. If you just say, I want Cat5e, you're probably not going to get this test. You actually have to call it resistance and balance as an additional measurement requirement. And then if you push back, oh, mate, it's going to add so much time. That's about a second to the auto to do that measurement.
Time to consider a different installer. Hey, I'm not sure if we've released our whole plans of these weekly webinars, but we are planning to have one that is going to focus on what we call the modular plug terminated link. And we're going to go into some detail on that about the different types of plugs that you can put on the far end of the link if someone would like more details on this.
Hey, Jim, I see you've brought up the website. I keep getting asked, a lot of people are very interested in that limit lines document. Could you show us very quickly how to get to that?
We're going to jump into support.
Hey, Jamie, you just need to speak up a little bit there for us.
Okay, sure. Thank you. We're going to jump into support and downloads and updates. And then from the downloads and updates page, it'll either be right there for you or select any one of the Versiv products, the DSX, the Certifiber, the OptiFiber, and on the DSX page, and this is actually going to be a helpful thing to look at as well. Come on, DSX page. I know you want to work. Oh, we're already on the DSX page. So what we're going to see is the new firmware for the DSX, the new linkware software, the results management software, instructions, and then here is that limit lines document that we can just click on and download. As Mark said, I think there's no cost for this. It may be a registration. We like to know who's interested in these things. We'd like to share information with you, and if you're interested in this document, probably be interested in the information that we have to share with you. Folks, 15 minutes. I really appreciate the audience hanging in with us out there. Again, we're having fun. This is our, I hate to say it, it's a little sad, but this is our water cooler conversation. Hey, what have you seen today? What failures have you had that's interesting and it gets us talking? I wanted to share some of these conversations with you. Mark, perhaps you have some closing remarks?
Well, I guess the only thing is that you know, we do get questions, you know, and there's a couple more now, but we're gonna cut it off now. You know, feel free to send those in to info@flukenetworks.com. You know, we're always there to try and help people out. We really pride ourselves on having an excellent team in our technical assistance center that we went through and added up the amount of cabling experience that's in that team, and between all our teams worldwide, we've got over 200 years of experience in the cable testing business with those people. So they know how to get answers to the questions. If they don't know the answers, they'll come to people like you're hearing here, and engineers, people on standards committees. We've got a lot of people that can help support you to answer your questions and get your job done. So, you know, feel free to ask us those questions, because when you're calling in and talking to us or sending emails, you're actually talking to people who really have some experience, know what they're doing. The other thing maybe I'll mention is if you're looking for fiber testers, now's a good time to buy them. Jim's got the website up there. If you go to our homepage, you can see we've got some great deals going on fiber, and I won't go into them now, but I'll let you have a look at them and you can figure out if they're what you need. Aside from that, I think we're done for the day. So I'd like to thank everybody for taking part, and have a great day. Thanks, Jim, Adrian, and Carolyn for helping answer the questions. And we'll talk to you all later.